external influences.
Yeah. Correct. Very good, very good. So, spontaneity means the no spontaneity. If you said that is any process, you can say any process any process is going to happen or not, is going to happen or not. Okay, happen or not.
Mm-hmm.
So that is what that is spontaneity. Generally, in the terms in our curriculum, they said the spontaneous means the quite fast process, or the process taking place itself. You can say the very simple one is process taking place itself. Process taking place itself. Taking place itself. So if anything is happening by its own, that is what is called, that is a spontaneous process, right? Now, if you talk about like that, the water is falling from the in the river. You can see water is falling from the up. So falling from the up to down, it is the spontaneous process. Nothing, you are not going to do any work. But, falling towards the gravity, it is by itself. Yes, yeah, no.
Yeah.
Falling of the fruits from the tree, that is very much a spontaneous process. Okay, so this type of process, if taking place by itself, that type of process is known as a spontaneous process, right? Now, if you talk about uh, the same one is spontaneity is studied under the term entropy. I know. So any
Mm-hmm.
process is going to be the spontaneous or not. That is the study in the form of the entropy or the gives free energy. Gives free energy. So gives free energy. So if I will ask that any process is going to happen or not happen, that which one is going to define either the entropy or the gives free energy. There are two ways to measure that any process is going to be spontaneous or non-spontaneous. What is there? The condition is there entropy, that is represented by S. Okay, you can represent delta S, and the Gibbs free energy, that is delta G. Okay, can you be able to understand this one?
Mm-hmm.
So spontaneity and process is going to happen or not by itself. We are talking about by itself. Okay, here you are not going to do any work. Process taking place by itself is known as what is spontaneity. So now we are going to understand that is entropy in the term of spontaneity is studied under the categories of the heading, that is entropy and gives free energy. Okay, now let us
Okay.
see that is now we are talking about entropy. If you talk about entropy, have you heard the word the entropy? Anything about entropy?
Yes.
Uh,
Entropy, I think if I remember correctly, entropy was like it first of all, it allowed me to determine whether a process was endothermic or exothermic.
yeah.
And it was like the thermodynamic quantity
Mhm.
representing like the energy in the system.
Yeah, super. 99% you said correct only. So here the exact definition I'm writing. It is a measure of randomness of system. You're talking about, it is measure of randomness of system. Randomness of system. That is what the total crux of this meaning. That is, it is measure of the randomness of the system. Entropy means measure of the randomness of the system. What is second point? What they said, it is the second law of thermodynamics. That is what the second law of thermodynamics said. That is entropy of the total universe is increasing. Okay. So here see, that is entropy, entropy of universe, entropy of universe, UNIVERS, universe is keep on increasing, keep on increasing. Okay, keep on increasing,
Hmm.
keep on increasing. So entropy means increasing, INCRES. It means if I will define these terms, what is meaning of this one? That is you can say that is randomness. You know, that is
Hmm.
randomness of universe. Universe keeps on increasing. universe keeps on increasing. Randomness of universe keeps on increasing. Can you be able to understand? Means
Yeah.
total world where the earth is randomized, more the randomness are increasing, right? So more the
Mm-hmm.
randomness are increasing, that is entropy also increasing. How, if you are defining this one, let us try to write in the, so entropy is measure of the randomness or the disorderness of the system. So wherever the entropy of the universe, here you see entropy is measure of randomness, or on one more word you can see, or disorderness of system. Disorderness of system. Orderness of system. So any system is how much it is disorder, that we are going to study under the heading entropy. Okay. So I'm erasing this one and writing the
Mm-hmm.
mathematical equation. Mathematical. Mathematically. Mathematically. Entropy, if you are talking mathematical, entropy is ratio of what? Ratio of heat absorbed, or that is his heat change. Okay, heat change with, okay, heat change with temperature. Okay, heat
Mm-hmm.
change with temperature. So this is going to be what? Mathematically, entropy is the ratio of heat change with temperature. Okay, so means that is, if you are talking about delta s, so how much that is heat is supplied, that is delta q. In the reversible process, they talk about the reversible process that taking place both the side. If the heat is decreasing, so randomness decreases. Suppose if you are having the water, so if water is temperature is very low, so water is temperature is very low, it becomes the ice. Yes, yeah, no.
Mm-hmm.
So means the
And what is delta S? Sorry.
delta S change in entropy.
Change in it. Okay.
Change in entropy. That little bit I'm explaining. Change in entropy. Change in
And
entropy.
Q is the heat, right?
Q is his, and T is the change in temperature. Okay.
Change in time. Okay.
This is going to be what? Change in temperature. Change. Asa, too much sound is coming here. Change in temperature. Change in temperature. Right. Is it okay? This is the change
Yes.
in temperature or temperature increase. This is the energy absorbed. Here is heat absorbed. The best word is heat absorbed. Heat absorbed. So change in entropy. So this is what the first formula is there. Second formula, if you are going, that is in the term of reaction. If you are talking about the in the term of reaction, so delta S is equal to change in entropy. So delta S product. Okay, we are have the, you can put out the summation also. So maybe the
Mm-hmm.
product may be the more than one. So delta S product means entropy of product minus that is summation entropy of reactant. This is the second. These all are there in your books only. From there, I just have seen this.
Mm-hmm.
Suppose it is the standard case. Standard case means temperature is 25 degrees Celsius, okay, or
Mm-hmm.
298 Kelvin, and pressure is 1 atm. So if they are talking
Yeah.
about, if someone is saying that is what is standard entropy. So standard entropy means everything is the fixed. So here is the, we are putting the not. Not means what? That is standard. So entropy of product minus entropy of reactant, it is there. Okay. Can you be able to
Mm-hmm.
understand this one? Okay. There
Yep.
is no as such, that is definition is not, derivation is not there. Just mathematically they are said, that is the, when it will be positive entropy will be more, or when it will be the negative and entropy will be less. It means if you are increasing the temperature, they said, if you are increasing the temperature or heat absorb more, if the heat increases more, so what they said, that is entropy will also increase. That is what the point. So let me
Mm-hmm.
try to write the another definition. If you are talking about delta S total, if entropy total they are asking, so delta S they are talking about system. Okay, this is system. And second one, delta S, that is surrounding. So if you are adding system plus surrounding, so that is, it is going to give, that is total, total entropy. Okay. So these are
Okay.
the three formulas were there, that we need to solve the problem based on it. On all the three formula, the problems has been given, that let us try to understand. So the entropy is the ratio of the heat absorbed or heat change with the temperature. And second one, entropy is equal to entropy of product minus entropy of reactant. And second is total if entropy you are calculating. So entropy of the system minus plus entropy of surrounding. One more is there if initial and final is given. So that is if the initial entropy is given and final. So how much delta S if you are
Final
calculating?
minus initial.
Thank you very much. Delta S fine. Thank you very much. That is delta S final minus delta S initial. So
Hmm.
that is what you said. No, exactly correct one. So these are the some formulas. Can we start the solving problem based on it?
Yeah.
Okay, thank you. So I'm giving you the problem. I'm writing the problem here. Let us try to solve. Okay, problem number one. If you are talking about problem number one, so they are saying heat of fusion. How they wrote that is heat of fusion. Heat of fusion of ice. Okay, of ice is how much? 6 kilojoule per mole. They are talking about. Q unit we have to take joule per mole. Okay, in formula here whatever the formula we wrote, Q will be that is joule per mole. Heat absorbed means joule per mole. Joule per mole. And temperature is degree Celsius. Temperature is degree Celsius. No, Kelvin. Change in temperature. If the Kelvin, it will be in the Kelvin. Kelvin, you know very well,
Okay.
Kelvin is equal to
Yeah.
0 degree Celsius plus 273.
273.
So this you may be knowing very much. So here is kilojoule per mole they have given. We need to change. Then calculate. Okay, they are saying calculate the change in entropy. Calculate the change in the entropy. Change in the entropy of fusion. Entropy of fusion. They are saying fusion
Hmm.
of ice. Okay. So see, we should know that is entropy of the fusion. It means we have to see that is at what point that is the solid get melt. So melting point of ice we should know. Melting MP of ice.
Zero.
Thank you very much. So it is 0 degree Celsius. Because fusion means what? It is converting into the different states. So how we
Yeah.
can be able to solve if you are talking about 0 degree Celsius in the Kelvin, it means
273.
thank you. 273 Kelvin. So how much is coming? Can you calculate? Delta S is equal to
So
uh,
Q over T. So this is going to be
uh,
6,000 because it's 6 kilojoules per mole
thank
divided by 273.
you.
So that should give us, I think, 22.
Hmm. So around 22. Here is the joule. Then unit will be what is going to come? Kelvin inverse.
Joule divided by
Kelvin.
mole times Kelvin.
So mole inverse also it will be there. Can you?
Yeah.
Is it okay? Will it be
Yeah.
okay? Thank you.
Yeah.
Okay. So I am again changing this one. Right? Can I change?
Yeah.
Okay. Thank you. So let me try to write one more problem. Little bit problems are quite larger size. They are saying entropy change for vaporization of liquid is. They are saying delta S. Okay, they have already given delta S change for vaporization of liquid. Vaporization of liquid. Vaporization of liquid. How much is there? They are talking about liquid is how much? 109.3 joule Kelvin inverse mole inverse. They have the given unit. Okay.
Hmm.
Next point, molar heat of vaporization. They have given molar heat of vaporization. Molar heat of vaporization. Molar heat of vaporization means what they have given, Q they have given is how much? 40.77 kilojoule per mole. See the unit. Kindly keep the unit. Here it is given kilojoule, here they have given joule. So always we need to keep in mind. Okay. Calculate. They are saying calculate the boiling point of the liquid. Calculate the boiling point of the liquid. See? Boiling point of the. Can you be able to solve?
Yeah, so boiling point of the liquid will be
Hmm,
the heat of vaporization Q divided by delta S.
hmm, hmm.
So this is 40.7 kilojoules, right?
Kilojoule is there, but we need to take in the joule now. We need
In
to
joules. So we take
uh,
so we take
one kilojoule.
40,000
Yes, 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 yes.
we
So
take 40,700 joules divided by 109.3.
yeah, yeah.
So 40,700 divided by 109.3 will be around 372 Kelvin, which should
Approximately
be about
this one.
approximately 99 degrees Celsius.
So 273. This is going to be in the Kelvin. It will kill.
Yeah,
See the Kelvin, or that is
mhm.
you can say 100
100
degrees.
degrees Celsius.
So that is what exactly coming boiling point. Boiling point of water is the same. Yes, yeah, no.
Yeah, yeah.
Okay. So this type of problem you will be able to solve. There is nothing is difficult here. Let me check if anything I can find little bit. Yeah.
I just have a question.
Uh-huh.
So when we're thinking of exothermic and endothermic processes, when will delta S be positive and when will it be negative?
See, for this case, if you are talking about exothermic process and endothermic process, let me see. Wait. 1 second. It is the endothermic process and exothermic process you are talking about. I'm changing the page, then I'm explaining. Okay. See, if it is the endothermic, right? So they are saying that is heat is absorbed. Heat
Yeah.
is absorbed. Heat is absorbed. Now you are talking about the sign. Okay. You are talking about the sign of the delta S. That I think that you are asking.
Yeah.
So delta S, if you are talking about, so how they have defined that is it is the positive. Positive means that is endothermic, exothermic. We cannot say in this quarter because positive.
Okay.
This one we cannot. So positive Q upon temperature. This is the case was that is exothermic. And in
Mm-hmm.
case of endothermic, suppose this is the negative sign is there. Endothermic means heat absorb. You can be able to understand. It's very simple.
Yeah.
Heat absorb. So it will be the negative.
Mm-hmm.
Second one is if you are talking about exothermic. So delta S will be what? That is the positive Q upon T. Now,
Mm-hmm.
what is coming out of this? Suppose that is delta S came negative. Delta S is coming negative. Okay. So randomness decreases.
Mm-hmm.
Randomness decreases. This will come in the next question. I think after 2 3 question decreases at delta S more means that is positive means randomness increases. Randomness
Mm-hmm.
increases. There is convention is there. Convention is what they are saying. More number of product form. If more number of product is there, more number. So more number is there, so they are going to collide more. So that is delta S will be positive, right? This positive.
Right.
Now less product is there, less number of product. Yeah, less number of molecule. Less number of product means that is they are collide less. Their randomness they will be less. So that is delta S will be negative. Like see, suppose this is the number of particle are there 4. So that is they are bombarding itself by very less because number is less. Suppose here the number of particle or gaseous particle or liquid particle are more. So they are collide very much. So delta S here will be positive and here is delta S there will be negative. But if you
Mm-hmm.
directly saying that is what will be the exothermic, there is no relation as such, not there.
Okay, got it. Got it.
But in case of gift free energy, there is relation is there, but case of entropy, I think there is not relation is there. In your book also it's not there.
Got it.
Okay, thank you very much. I'm erasing. Can I erase this one? Okay, thank you. I'm giving you one question. I'm searching the one question. Let me check the question. If anything is better question, I will find. Yeah, I got the one question. If you try to solve it out, question is there saying the enthalpy of vaporization. Enthalpy of vaporization. Enthalpy of vaporization means they have given boiling point of liquid, and liquid they have given C2H5 twice O is how much? 26 kilojoule per mole, right? At its boiling point. At its boiling point. Now, boiling point and its boiling point. At its boiling point. hmm, hmm, if its boiling point, if its boiling point is 35 degrees Celsius, 35 degrees Celsius, calculate delta S naught. They are saying calculate delta S naught. Please try to calculate.
So the enthalpy of vaporization is if its boiling point to 35 degrees. Okay,
So see,
so we can say that Q is equal to 26 kilojoules per mole.
hmm, 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 hmm. So here is that is the delta H vaporization they have given enthalpy. Either you say heat or enthalpy, both are the same term, right? Heat and enthalpy both are. No, both are the similar things are there. There is a little bit difference is there, but when you will study more, enthalpy is the if we talk about at constant pressure is there at constant pressure. No, they are talking about at constant pressure. Later on, you will be able to understand when that is relation will come Cp minus Cv. There maybe you are going to study. So in the Mayer's equation, you are going to find that is enthalpy. I mean you will be able to understand heat and enthalpy both are the similar terms.
Yeah. So just
So,
be enthalpy divided by the temperature.
hmm. So you see that is what their enthalpy of vaporization they are saying 26 kilojoule are there. It means that
So
is we have
26,000
26,000. Temperature 35 degrees there, 35. So we have
8 Kelvin.
273. Yes, now. So 26,000 divided by I think 8 0
26,000 divided by 308, right?
308. Okay. Here is the joule per mole it will be there, and here is Kelvin. So whatever is coming in this one, joule
84.
mole inverse Kelvin inverse. How much is coming?
84.4.
Thank you very much. 84.4. Okay, joule mole inverse Kelvin inverse. So I think it will be okay to you to understand this one.
Yeah.
Yeah, that much only. Now I'm changing the formula and going for the second formula. Can we go on the second formula problems on second formula?
Yeah.
Thank you. So here we are going for the this chapter is quite critical. Okay, to connect it with the in your this chapter they have given directly they come out and too much theory are there. I didn't go with the theory. Okay, so directly I'm explaining you the numerical problem. In the next class, if you study the same little bit, I will give little will take I will take 10 to 10 minutes of this. Okay, to explain the theoretical portion, whatever is there. I will read out and I will explain that one. Because my health was not okay yesterday. That is why I didn't see that at all.
How are you feeling now?
And now it's okay. Actually, I went for the as a examiner for the conducting practical. So that there's so much in India that is a 50-degree, 55-degree heat is there.
Oh my God.
50 degree, I think 50 degree, 12 o'clock, 3 o'clock means around 48 to 50 degree must be there. So that I got in the heat. Okay, by the way, now I'm okay. Here, Surya, we are going for the second formula, problems on second formula. Problems on second formula. So second formula in the term of product and reactant. So delta S, okay, of reaction, delta S reaction is equal to, just now you told, that is summation of delta S not product, S not product, minus summation delta S not reactant. If that is standard, they are saying that is the, we have go for the standard. If standard they have not given, the normal we have to go. Okay, standard whatever they have given, that is data we have to find out. Question they are saying, that is calculate. Okay, calculate delta S naught at 25 degrees Celsius for the reaction. For the reaction. Okay, this is the point.
Mm-hmm.
Delta S naught they are asking, but they have given from the 2NIS, this is the solid state, plus 3O2, that is going to be gaseous state. Here is, that is 2SO2, that is again gaseous state, and 2NIO solid state, right? From the they are saying from the following datas, they have the datas they have given from the following datas. Okay, so what are the datas are there? See, SO2 gas is there, and here is what they are saying, enthalpy they have also given, enthalpy. Okay, SO2 gas, and they have given the enthalpy also. So what are the things are there? If you talk about SO2, if you see, 248, 248. Okay, and these are the, I will tell you the unit, how much, what NIO, NIO is 38. Then they are talking about O2. O2 is 205. Then you are talking about NIS. NIS is 53. So here is the, this is gas, this is going to be solid, this is going to be gas, this is going to be solid. These are the points. So for these things, they have given the, okay, and these all are the Joule Kelvin they have given. So means that will be the Joule Kelvin per mole, that is same will be there, Joule Kelvin. So let us try to understand here what are there, how to write the, first of all, we need to understand how to write the equation for this one. So delta S reaction, if you are they are asking, so we need to go for the product. Product, if you see, the product are the 2 is there, delta S, not SO2 we will write, because 2 mole is there, so the 2 time, then plus 2 mole is there, and the product we have to talk about delta S we have to go. Okay, 2 mole, that is delta S, what will be there, not NIO, then it will be minus. If you are going minus, how much is coming? You can see the, what are the reactant are there, 2 2 delta S NIS. Okay, 2 into, we can write 2 into delta S NIS, then what is there, 3 delta S naught, delta S naught is there, delta S naught O2. So they are there. Now what we are going to plug the value, SO2, you can see here, SO2 value is there 248. So here is the 248, then positive. So here is 2, NIO is there, so that is what, 38. Okay, now you can go for this one. If you are multiplying by minus, this bracket everything will be the negative, yes, yeah, no, yeah. So 2 multiply by NIS, NIS, where is last one, that is 53, and this term also become the negative. So negative is 3 multiply by O2, O2 is 205. So, this question is the example of your book only, directly it is the example of your book, I'm taking your book. So let us try to solve it out, how much the value is coming. If you multiply these two, so it is coming 498, 496. And if you are multiplying this one, this is coming 76. If you are multiplying this one, it is coming 106. And if you are multiplying, this is the 615. Now you can, okay, you solve this three, this the terms. Okay, can you be able to solve this one? How much is coming?
So it's going to be 572.
Hmm.
572 minus 721.
But
So this is going to be 572 minus 721, which is going to be negative 149.
it will be joule per Kelvin. Now you see delta S reaction is coming, what that is negative is coming. Okay, means randomness decreases. It means randomness decreases. Randomness decreases. अब randomness of the system decreases means less number of product is there. Less number of product will be there. 100% the number of product will be less. Okay. So now go with the check with the equation. See, if you are checking the equation, what you are going to find? How many are there here? You see, 3 to 5. Yes, yeah, no. 5 are there. How many here are there in the product? Product you see 2. Yes, yeah, no.
4, right? 2 into 4.
2 and 2, that is 4. And here is 3 to 5. So number of product decreases. Number of product decreases. It means entropy will decrease. So randomness decreases, less number of product. Can you be able to understand this point? If you don't mind, please, can you write down this one? Done.
Yes.
Okay, thank you. I'm giving you one more question. You try. I think you will be able to try this one much better way. So I'm just giving you the problem. You just try out. So here I'm writing question. Calculate. Here they are saying calculate delta S naught for reaction, for the reaction of aluminium. They are talking about of aluminium oxide by hydrogen gas. By hydrogen gas. So here they wrote that is Al2O3. This is the solid plus 3H2. This is the gas. Here is 2Al. This is going to be solid plus 3H2O. This is going to be gas. They are there. And some values they have given. Substances are there. And here is the enthalpy they have given. Entropy is standard value, joule. Then they are talking about Kelvin and mode, joule per Kelvin. What are there? If you're talking about Al2O3, this is given 51. H2, if you are talking about 131. Aluminum, if you are talking about, here is 28. And H2O, if you see, they are 189. So can you please solve and tell me the answers? This is also from the your book. I am just writing from the your books only.
This is going to be so this is going to be so this will be first 2 times Al, which is so 2 times 28, which is 56, plus 3H2O, which is 500 and so 189 times 3, so 189, 5 times 3, 5 times 3 is 570.
393.
567. And then we have that minus the reactants, which is going to be 51 plus 3H2, which is 393. So the final equation will be 623 minus 444. So delta S will be 179.
Thank you very much. Delta S is equal to plus 179. Means number of product increases. Number of product increases. That is what you can say, that is randomness increases. That is why positive coming na. Randomness of system increases. Means particle are colliding more. Randomness of system increases. Okay. So that is the okay. That become the randomness of system increases. It means you see, if you talk about this one product, how many are there? 2 plus 3 is equal to 5. Here you can see that is how many are there? 1 plus 3. How much? 4. So if the number of the product increasing, so that is entropy is coming the positive. Yes or no?
Mm-hmm.
So that is what the two question. Here you see number of product were decreasing. 4 were there and this side 5. So entropy was decreasing. It means randomness decreases. So you wrote this one. Can I give you one more problem? Why you want to solve that one?
Sure.
Okay. This time the data has given the in the word form here. Question they are saying determine. Here is determine the entropy change. They determine the entropy change. Determine the entropy change for the reaction given below. For the reaction given below. Here they are given below. So here they are talking about 2H2 gas is there plus O2 gas is there. They are giving that is 2H2O liquid, right? What is at? They have given temperature at 300 Kelvin, right? 300 Kelvin. If standard standard means that is S. If standard entropies of standard entropies of H2 gas, then they are talking about O2 gas and H2O liquid. H2O liquid are how much? Are 126.6, 201.2 and 68 joule Kelvin inverse mole inverse respectively. So your answer, you need to solve this one. A number option they also given minus 112.4 joule Kelvin inverse. B number option they are saying minus 318.4 joule Kelvin inverse. C number 501. This is the joule Kelvin inverse. D none. Will you be able to solve this one?
Yes. So the answer will be B negative. One second. So the entropy change for this will be is it just this is going to be 2, which is negative 250. I'm confused between B and D because
Mhm. D
because
is
this
not
is
there.
water.
D.
So the answer B.
Yes, correct. So this is
The
what we will.
question is like usually when we did equilibrium, we didn't include any. We usually used aqueous solutions and we didn't include liquids. In this case, do we include all substances that are there?
Yeah. All the states are all the states here they are talking. If they are talking about it, the solid is there. So its entropy will be very less. Maybe it's zero. There the rule is there. See here. What is the third law of
Lights are
thermodynamics?
included.
Here the see the first law is not there in your syllabus. Second law is the entropy. Third law of thermodynamics, if you talk about third law of thermodynamics, what you ask that question? Third law of thermodynamics. Okay, thermodynamics. What they said, third law of thermodynamics, it said that is entropy of, but entropy of perfectly, they are saying entropy of perfectly crystalline solid substance is, okay, substance is zero zero at 0 degrees Celsius. Okay. So what do you talk about? That is the if it is the solid. Solid means the low entropy. Low entropy in the solid, particle are less randomized. If it is gas, high entropy. High entropy. Okay. High. See, that is why the gaseous reactions are much faster compared to the solid reaction. Solid reaction are very rare to occur. If you are heating the metal with the oxygen, it requires too much energy, too much heat is required. It means that is that they are not spontaneous. They are not going to be the spontaneous. Yes or no? Because you need to supply so much energy. But the gases in the environment, you need to see gases in the environment. They are actually easily getting react. Okay, like nitrogen and hydrogen, they are reacting, they are forming the ammonia. Okay, so many gases are there, like sulfur is getting burned by itself due to heat, and sulfur dioxide is getting formed by itself with the oxygen. Okay, you need not to do. Why? Because the substances which are in the gaseous state, their kinetic energy are high. So what they
Yeah.
do, they easily combine and they give the product. But if you talk about solids, suppose NaCl is there. NaCl, the particles are very closely packed. They are not going to react easily. So what you ask the questions, that is correct. That is, if it is in the entropy, you have to take all the things, because in the solid, if it is not perfectly solid, little bit particle may be moving, so little bit it may be vibrating. Yes or no?
Mhm.
So that is, there may be the entropy little bit. Definitely, they will participate in the entropy. Can you be able to
But
understand? Huh.
yeah.
You are asking anything more?
Oh no, that was my question.
Okay, one equation is there that we will go the equation in the next class. Okay, definitely
Yeah.
I'll teach you that point also. Next one is, that is to know the process is spontaneous, like that is spontaneity we study na, is spontaneous. So spontaneous, how to know? The entropy already they tell, the entropy. Now second one, they are talking about Gibbs free energy. Gibbs free energy. If you defining Gibbs free energy, there is no exact definition is there, but this is the amount of energy, they are saying amount of energy used to do useful work, useful work. So that is amount of energy used to do useful work. This is what the Gibbs free energy, and this is the they have given by the equation delta. Either if you are writing that simple, you can write this is uh, G is equal to, you know, H minus T delta S. H minus Ts, simple is there. H minus Ts. Now see, these are what? So here is, this is the entropy. Entropy. Here is, this is the temperature. Temperature. This is what is, that is enthalpy. Enthalpy.
Mhm.
And now this is the Gibbs free energy. Gibbs free energy. Gibbs free energy. What is the name of the equation if you talk about? Gibbs-Helmholtz equation. This equation is what is named as Gibbs HELM. This equation is there in your syllabus. So that I'm teaching you Gibbs-Helm, HELM. Helm, HOLTJ, Helmholtz equation.
Mhm.
This is Gibbs-Helmholtz equation. So G is equal to H minus T delta S. Okay. Now, with the help of this, we need to determine that any process will be spontaneous or not. We need to determine. This is given by Gibbs-Helmholtz equation. There is no derivation. Directly, we need to use this one, and we need to solve the problem. Okay. In your book, there are some relations are there that I will tell you. But firstly, let us try to explain the simplistic one. Can I erase this one?
Yeah.
Okay. So if they are saying, if that is gives free energy, gives free energy, gives free energy. So here you see point number one. So they are saying, if delta G is going to be negative, you know, if delta G is negative, the process is in spontaneous. The process is spontaneous. If delta G is negative, it is process is spontaneous. That means taking place itself, taking place itself, taking place itself. You need not to do anything. if delta G, second point, if you are talking about delta G is equal to 0, the process is at equilibrium. The process is at equilibrium, at equilibrium, at equilibrium. That is a reversible process. That is reversible process. That is reversible. Last one, third point. Now, what the third point they are saying, if it is the positive, they are saying if the delta G is equal to positive is coming, the process is non-spontaneous. Process is non-spontaneous. Non-spontaneous. Non-spontaneous means non-spontaneous, that is do not takes place itself. Do not takes place itself.
Mm-hmm.
So very basic style I am teaching you. Okay. But they will ask in the detailed way that I will teach you. That is the when it will be the negative, when it will be positive, I will teach you. Okay, in the next class, not this class. Today we'll solve some problem. Next class I will tell you the some convention of this. So can I erase this one? Okay. So the one formula you got to know, delta G is equal to, okay, here is G is equal to H minus Ts as there, Ts was there. If suppose Gibbs in change in Gibbs energy, delta G is equal to delta H minus T delta S. Delta G is equal to delta H minus T delta S. This is the point. This is the first formula which is used. The second formula they are doing, delta G naught is equal to delta G naught formation of product. Okay, they are talking about delta G naught product minus delta G naught formation. That is going to be what? Reactants. Reactant. So delta G naught product minus delta G naught reactant. These are the two formulas are there. So can we solve some of the problem based on it, if you don't mind?
Sure.
Okay. Some of the problem I'm going to solve here. Some of the problem I'll send you. I'll mail you. You can check there. So question I'm writing. Question. Calculate the standard gives free energy. Calculate the standard gives free energy. They are saying gives free energy change. Gives free energy change from the free energy of formation, free energy of formation data, free energy of formation data for the following reaction, for the following reaction, for the following reaction. So what are there? Here they have given the one reaction C6H6, this is the liquid, plus 15 by 2 O2, this is the gas. Here you see that is 6 CO2, this is gas, plus 3H2O, that is gas. Given that something they have given that what is delta Fg naught C6H6 they have given for the liquid, C6H6 for liquid they have given 172.8 kilojoule per mole. Okay, so unit will be for the Gibbs free energy. It units can be either joule per mole or kilojoule per mole. You need to see the unit what the data is given. Second point they have given delta Fg naught CO2 they have given. This is the gas. How much? Minus 394.4 kilojoule per mole. Delta Fg naught H2O liquid they have given minus 228.6 kilojoule per mole. Right. Last one. Delta Fg naught O2 gas is 0. So they are asking this one. Okay. Option they have given here. 324.6 kilojoule per mole, means the same Unit we need not to change. Second one, minus 32246 kilojoule per mole. C number, minus 322 joule per mole. D, this is none. So what we are going to do, first of all, see, for this one already they have said that is 0. For this one they have given, are you solving? Are you solving?
Yes.
Okay, thank you.
One second. So this is going to be 172 times, so they've given 6 CO2. So it is going to be so this will be 6 times 6 times 394. So but it's negative.
So which one is coming?
1 second. I didn't realize there was a negative. I have to account for that. So this is going to be 6 times negative 394.4. And then I add that with negative 3 times negative 228.6. Negative 228.6, and then that will be added with sorry, 1 second, I'm just having a hard time calculating it. And then that will be added with 172.8. So that gives me, I think I got the wrong answer because I'm getting 2,880. Negative
See how much is
2,880.
coming. See how it is coming. Kilojoule per mole. See, it is coming this way. All get added now. If nothing you are subtracting,
sorry.
all get added. All are
Yeah,
the
I got
negative
that.
term.
Yeah, I added
Because
172.8.
here it is positive, but again you multiply by the formulas, because in the formula what are there? Negative. So if it is the positive symbol is there, means again it is going to be negative. So every value become negative, so it is coming minus 3224.6. So correct option is, I think, option number E. Can you understand this one?
Yeah.
Okay. Some reactions are good here. They have given so many reactions. Let me try one more last reaction. So in the next class, we'll try to teach you some of the other convention, whatever the convention are there. Here. Calculate. They are saying calculate. Gives free energy. They are saying delta G naught for the following. Only the calculation is there, that nothing is there.
I think the screen stopped sharing.
Yeah, now it's came.
Yeah.
Now it's came. Yeah. Following. They are saying following reaction. Okay. So they are talking about Ca solid plus Cl2 gas, and here they are talking about CaCl2 solid. Oh my God. They have given so many. This is the A number. Again, they have given B number, HGO solid. Then talking about this is converting into HGO liquid and 1/2 O2 gas. Okay. C number they are talking of. Any one you have to calculate. NH3 gas plus 2O2 gas. It is giving, that is what, HNO3 liquid plus what, H2O liquid. Any one you need to solve. Okay. These are all the value. For CaCl2 they are talking about minus 748.1 kilojoule per mole. Right, this is there. They are talking about HGO. HGO value they have minus 58.84 kilojoule per mole. If they are talking about NH3 value, they have given minus 16.4. 5. Same unit. Here is HNO3. They have given minus 18.71. 18.71. And H2O, they are talking about minus 237.13. And O2 value, they have given 0. So this is the delta S value for this, all the things they have given. And now they are asking to calculate any one of this one. So if you can calculate any one of this one, can you try this one?
Oh,
First
these are
one.
the delta S values.
Delta S for what? CaCl2, like this value they have given. And they are
Mm-hmm.
asking enthalpy of reaction, delta Rg naught. So this one given, this one given, this one given. So we can apply na delta G, delta enthalpy of reaction. Rg is there. Enthalpy of reaction means what?
Yeah.
Delta G naught product minus delta G naught reactant. So
Yes.
product is what there, CaCl2 is there. So we can
Yeah.
write that is gives free energy, means delta
Mm-hmm.
G naught, that is CaCl2 minus uh, what it is going to be.
This is going to be Ca plus Cl, delta G of Ca plus delta G of Cl2
Uh,
added together.
so delta G Cl2. For Cl2, they didn't give anything. It means C. Ca is the, if I'm writing one word here, if you can remember, no. In elemental state, the enthalpy of formation is 0. The enthalpy of formation is 0. Enthalpy of formation is 0. Why 0? As they are, as they are already formed in nature. Already formed in nature. In nature means what they are saying. Suppose they are asking calcium. So delta G naught value is 0 because calcium exists itself. You are not forming here in the reaction. If it is the
Mm-hmm.
O2 is there, itself is forming. So delta G naught is equal to 0. If other is what is there, Cl2 is there. Itself it exists in this form. You are not going to prepare. It exists in the nature in this form. So that is delta G is equal to 0. So now you apply this concept. So CaCl2, this is the product, so they have given. So how much given? That is minus 74.748.1. And here is calcium, this is 0 plus Cl2 0. So here the answer will come minus 748.1 kilojoule per mole. Okay. So that
Got
is
it.
delta Rg naught. This is coming negative. Negative is coming. It means that is spontaneous. If anything is coming, is that is spontaneous process. Spontaneous process means taking place itself. Taking place itself. Taking. So they are the active metal. Now they will taking place itself.
Mm-hmm.
They are active metal, so that they will combine by itself. So this is all about the gives free energy. Little bit I will take some more time to solve some to provide you some convention and some theory I will explain you in the next class. Okay.
Got it. Thank you, sir.
Okay, very most welcome to you. Thank you very much for changing the time. Uh, Maybe if I will change, kindly consider that if some problem, because our college time has changed here. So I will
Mm-hmm.
request to change, that is Saturday to Sunday. Okay.
Ah, so that's no problem. I can do Sunday too.
So okay. So next Sunday we'll do in the same timing. Okay.
Sure. Thank you, sir.
Okay. Okay. Welcome. Welcome. Bye. 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 Take care.